let's change some volume units in the metric system. Right, so again, you're in the metric system, your prefixes, you'll have mega, and then kilo, hecto, deca, and then you go to your base, and then deci, centi, milli, micro, nano, and pico. So we have to know what those prefixes are, the order in which they are, and also how they connect to the base in terms of powers of 10 in order to be able to do conversions. So the first conversion we're going to do is we're going to change 0.5 liters to milliliters. Right, so liters is in my base, and I want to connect this to milliliters. So looking at this table up here from my base to milli, this is 1, 2, 3 to the right. So we're going to want to move this decimal right 3 spots in order to do our conversion. Right now the decimal is before the 5, so if I move it 1, 2, 3 spots to the right, we'll need to put in some filler zeros. So this ends up at then 500, and then my units are milliliters. Don't forget liters is capital L. If you wanted to set up a conversion factor, we could take the given information, which is the 0.5 liters, and put it over 1. Now, using the information in the table, liters is what I'm in and I want to get out of, so it'll go on the diagonal of where it was, so in the denominator of the second fraction. Using what's provided in the table to connect to milliliters, when this says 10 to the negative third, what this is telling me is there's 10 to the negative third liters in 1 milliliter. Right? Or if you wanted to write that in decimal form, 10 to the negative third would be 0.001. So 1 milliliter is 1/1000th of a liter. Right? And you could do 0.5 divided by 0.001 if you wanted to do the conversion. I tend to not set up my conversions using the negative exponents. Because I want to be able to analyze if I want to move the decimal point right or left and how many spots. You know, that's the beauty with the power of the 10. I don't necessarily need to have a calculator out in order to be able to do this, but the negative exponent's a little goofy. So instead of setting up my conversion factor like that, all right, so again, I'm just going to start with the 0.5 liters over 1, and liters still needs to be on the diagonal. But as opposed to setting up the relationship like this, where I have 10 to the negative third liters is equal to 1 milliliter, I like to think about this as I'll have to have 10 to the third milliliters, or 1,000 milliliters, in order to be equivalent to 1 liter. Working with positive exponents is nicer because it's easier to see what's going on. So in this case, then my liters on the diagonal cancel. Because I want to multiply the 0.5 times to the 10 to the third power, because we are going to be multiplying. That means I want to move the decimal point right. And then I'm going to move it right whatever this exponent is, or however many zeros there are if you want to look at that expanded form. So I'm going to move the decimal point right 3. Right, so if I move the decimal point right 3 spots, again, I end up with 500 milliliters for my final answer. All right, let's take a look at this next one. We're going to change 65 cubic centimeters to milliliters. So we need to recall that 1 milliliter is equivalent to 1 cubic centimeter. This gets converts us between our volume measured in our liquid units and on our volume that's measured in our cubic units. You could also equivalently use the fact that 1 liter is equal to 1,000 cubic centimeters. But because this is talking about milliliters and cubic centimeters, I'm just going to go ahead and use that relationship. So this is pretty straightforward, but if you wanted to set up some conversion factors to really see what's going on, 65 cubic centimeters, I'm going to put that over 1. The units I'm trying to cancel, which is cubic centimeters, so when I set up my conversion factor, the cubic centimeters information is going to go in the diagonal or the denominator. And then the relationship is 1 cubic centimeter is equal to 1 milliliter. So 1 cubic centimeter is equivalent to 1 milliliter. So I can fill out that information for the numbers and what's going to be in the numerator here. cubic centimeters, which is on the diagonals, cancel. My answer will be in terms of milliliters, and then to get this, I'm just going to multiply. So this is 65 milliliters. So what you're saying is that's why I was like, this is going to be pretty straightforward. It's a one-to-one conversion. 1 milliliter is the same thing as 1 cubic centimeter. So 65 cubic centimeters is also the same thing as saying 65 milliliters, right? So pretty easy. So we didn't necessarily need to set up the conversion factors, but if you're having trouble seeing it, the math will also get you there. All right, so for the next one, I want to change 2 cubic meters to liters. Now, I know for liters that 1 liter is equivalent to 1,000 cubic centimeters. But the problem on this one is I'm not in cubic centimeters, I'm in cubic meters. So the first thing I want to do is I want to convert my cubic meters to cubic centimeters. And then once I have my units in cubic centimeters, then I'll be able to use this relationship. So let's do 2 cubic meters. We'll put that over 1. Now there's a couple different ways to convert out this cubic meters. I like to build 3 fractions where each fraction will just have meters in the denominator. So I have technically 3 meters up there because it's a cubic meter, right? So I have meters on the length, width, and height. So I have to convert out the length, width, and height. So I'll have to set up 3 factors. If you wanted to, you could set up 1 factor and put an exponent of 3 on it. I'll show you that in a moment, but this is how I like to set it up to see. I start with 3, I have to convert out 3. Now again, what I'm trying to do right now is I'm trying to convert out from meters to centimeters. And the relationship, if I go back up here from my meters, which would be my base, to centimeters, is there's 10 squared or 100 centimeters in 1 meter. So I'm going to use, and you could write out 100, I'm going to use the 10 squared to finish writing out my conversion factors. So 10 squared centimeters in 1 meter. Now, at this point in time, my cubic meters will cancel with the 3 meters I have in the denominator. And then my ending units, I have centimeters here, and centimeters here. So putting those together, you get cubic centimeters. All right, so we're good in terms of having my units in cubic centimeters. Now, I could go ahead and convert or use these to figure out 2 cubic meters equals how many cubic centimeters. You know, I could get that number if I wanted to just by stopping right here. But I'm going to go the one step further because ultimately I don't want my answer in cubic centimeters. I want it in liters. So I'm going to set up my one more conversion factor. Now technically I have cubic centimeters in the numerator, so in order to get it cancels, I will want to put it on the diagonal or the denominator of this new conversion factor. And here's where I'm going to want to use this relationship that 1 liter is equivalent to 1,000 cubic centimeters. So 1,000 cubic centimeters, and I'm actually going to write that as 10 cubed. So for my 1,000, so 1,000 cubic centimeters is equivalent to 1 liter. Now my centimeters information up here, 1, 2, 3, cancels with my cubic centimeters down here. And now my final answer would be in terms of liters. All right, very good. That was a lot just working with units and powers of 10. So let's actually figure out what number I get right here. So I know my final answer is going to be in terms of liters. Looking at the calculations, what do I have? I have upstairs 2 times 10 squared times 10 squared times 10 squared. Do we remember what we need to do with those exponents on the tens? In order to be able to put them together, we're going to add them, yes, all right? So this ultimately gives me 2 times 10 to the 6th power upstairs. Downstairs I have a whole bunch of 1s, but then this 10 cubed. All right, and do we remember what we need to do to these exponents when they're on the opposite sides of the fraction bar and I'm dividing them? What do we do with those exponents then? All right, we subtract them, right? So this is then going to end up giving me 10 to the 6 minus 3, which is 3. Right, and then writing that out, this is going to be 2 followed by 3 zeros. So this is going to be 2 thousand, and then liters for my final answer. All right, so on this one, just to kind of summarize, in order to do the conversion, I know the relationship between liters and cubic centimeters, but I was given cubic meters. So we converted our cubic meters to cubic centimeters, and then I was able to then finally convert the whole thing to liters. All right, one more volume conversion. Let's convert out 4.5 cubic centimeters, and I want to convert that to cubic millimeters. All right, so this is converting out a volume. And there's a couple different ways that you could do this, but again, I like to, because I have technically 3 centimeter measurements that I have to convert out, so I like to set up 3 new fractions, each one of them with centimeters in the denominator, so it's on the diagonal of where it is. And then the relationship between centimeters, which is what I'm in, technically it's cubic centimeters, but I'm just kind of looking at that basic unit, centimeters to millimeters. Okay, we could come up here to this table if we were confused, but from centimeters to millimeters, there are 10 millimeters in 1 centimeter. So there are 10 millimeters in 1 centimeter. So that can finish my conversion factors for these 3 that I had set up. 10 millimeters in 1 centimeter. Now the cubic centimeters that I was given will cancel with the 3 on the diagonals. And then you can see what my left was millimeters here, and millimeters here. So ultimately my final answer will be in cubic millimeters. Now, how big is my final answer going to be? So my final answer is going to be 4.5, which is what I have right here, and times 10 times 10 times 10, which is times 10 cubed. All right, so multiplying this by 10 cubed means I want to move the decimal point right 3 spots. So I move the decimal point right 3 spots. I will end up at 4,500, and then my units are going to be cubic millimeters. Okay, again, this is why working with powers of 10 are so nice, because it tells you you're just moving the decimal point right or left. If you're multiplying by a power of 10, you move it right. Dividing by a power of 10, you move it left. And then the exponent tells you how many spots you're going to move it. Now, this is to show you a different way to set this up. As opposed to setting up 3 of the conversion factors, the shorter way to do it is to set up just your base conversion, which means the relationship between centimeters and millimeters is there are 10 millimeters in 1 centimeter. I'm going to need to do this 3 times because of this 3 right here. So if you wanted to, you could put parentheses around this whole thing and then just cube it and raise it to that same exponent for however many times you need to do the conversion. That's a little bit fancier, right? It'll still get you what you want. You still have your 10 cubed when you're done doing the conversion. But again, I like to kind of maybe expand it out on the stuff that we're doing because I can see it a little bit better. All right, now that was the last volume conversion, but just as a connection between volume and mass, they are 2 different ideas, but they are related. What is the mass of 200 milliliters of water? Okay, and it's kind of important that it's water because that connects to some of our definitions when we define things when we were working with masses in grams and kilograms. So what is the mass of 200 milliliters of water? So if you go back to some of your previous definitions, we had said that a liter was the same thing as the volume of 1 cubic decimeter of water, or 1 liter was the same thing as 1,000 cubic centimeters. We also said that a kilogram was the mass of that box. All right, so let's go back and take a look at that real quick. All right, so if I have this box, which is 10 centimeters by 10 centimeters by 10 centimeters, 1 liter of liquid would fill that box. And if that box was filled with water, that box would have a mass of 1 kilogram. This box has 1,000 cubic centimeters in there. A kilogram has 1,000 grams in there. Okay, so if I have one of the little cubes that make up this big box, so 1 centimeter by 1 centimeter by 1 centimeter cube, 1 milliliter would fill that box, but that box also has a mass of 1 gram. Right? Because in this box up here, which had a mass of 1 kilogram, 1 kilogram, kilo, so there's going to be 1,000 grams in 1 kilogram. So if this box has a mass of 1,000 grams, and this box has a volume of 1,000 cubic centimeters, then what must be true is 1 cubic centimeter filled with water, specifically, has to have a mass of 1 gram. All right, so coming down here to answer this question, if I have 200 milliliters of water, okay, so maybe I can redraw this to kind of summarize what we just explored. All right, so here's my 1 centimeter by 1 centimeter by 1 centimeter cube. Okay. If I were to fill this cube up, this cube can hold 1 milliliter of liquid. But if I fill this, so this is a volume idea. But if I take this same cube and I fill it with water, specifically with water, at its maximum density, it has a mass of 1 gram. Okay, so if I have 2,000 milliliters, or basically 200 milliliters, or 200 of these cubes, each one filled with water, each one of those cubes has a mass of 1 gram, so ultimately, when everything's said and done, this will all have a mass of 200 grams. So the connection is 1 milliliter of water at its maximum density has a mass of 1 gram.